All right. Good morning, everyone. It's Ty from Lambda School, and today I'll be going over sum and product for the CS1 class. All right, so sum and product is a function that reads, given a sum and a product, find two positive integers, x and y, where x plus y equals sum and x times y equals product. You will return this in an array. For example, calling sum and product of 6 and 9 should return 3, 3, because 3 plus 3 is equal to 6, and 3 times 3 equals 9. Please make sure to return your array such that x is less than or equal to y in the format open array x, comma, y. All right, so there's multiple ways to think of this. I like to think that sums are easier to calculate than products. So what I could do here is write a for loop, I equals 0, and then I is less than or equal to the sum divided by 2. Because really, you only really need to get halfway to the sum. Because if you do get over halfway of the sum, then either the product doesn't exist or you're going wrong somewhere. And then what I'll do here is I'm going to take what I have for I. So I'm going to write if I times sum minus I equals product. I'm going to return I and sum minus I. And if it breaks out of that array, or if it breaks out of that for loop rather, then that means nothing actually finished and I just return null. That's all there is to it. Did I lose anyone? Check if you're still following X if I've managed to lose you. Oops. Yeah, that's it. Sure. All right, Antonio, I'll look at your solution afterwards. But yeah, it's really short because the idea is if you got on a scale, if you got like, oh, let's do this example. So given a number 6, you can start with 0 times 6. Does 0 times 6 equals 9? No. Does 1 times 5 equal 9? No. Does 2 times 4 equal 9? No. Does 3 times 3 equal 9? Yes. Right. So let me crack open my tests and see what I can get. So for let I equals 0, I is less than or equal to the sum divided by 2, I plus plus. Because we know that it's a positive integer. Oh man. Josh indeed was trying to get fancy. If I times the sum minus I equal to product, return bracket I, sum minus I. Return null. Oh, I'm writing this in the wrong place. Student preview. There we go. Control V. All right. And then console.log, sum and product of 13, 12. We should get 1, 13. Or sorry, 112. 112, not 113. Because 1 times 12 is 12. Yeah, Antonio basically wrote my solution just a bit longer. Does it not? Find 2 positive integers. Yeah, 1 times 12 is 12. 1 plus 12 is 13. Julian's got O of 1 time? Really? 13 is right here, man. 13 is the sum. 12 is the product. Julian, why don't you post your code? All right, so let's do something else here. Let's put 36, 180. What are we expecting here? Wait, Julian, post your code. Now, if you have a rainbow table in your code, man, you went quadratic on this? Oh, man. uh, yeah, Julian's got me beat. He went quadratic, or used the quadratic formula. So, all right, last part here. 36 and 180 should be 6 and 30 because 6 times 30 is 180. 6 plus 30 is 36, right? So if we run it, we get 6 and 30. So theoretically, this should pass all my tests. So I wrote this as a brute force method, but if you know math, apparently like Julian does, or if he Googled it, I'm not sure, doesn't matter, figured out how to do it the quadratic method, so he actually would have a better time. So did you Google this, or did you actually figure it out, Julian? No, I'm not calling him out. Google is how you learn. Okay, yeah. No, good on you though. All right, cool. So let's show Julian's solution because that's actually O of 1 time. That is mad props, man. Mad props. Yeah, and it passes all the tests too. Negative b squared for AC. All right, I do actually have another appointment I do have to hop to, so no JS Perf today. Post my code for you before I go and post the video. Uh, da, da, da. But if someone wanted to whip it up, there's my code. Thank you for your time, y'all. I'll catch y'all later.